Instagram uses both SQL and NoSQL. So does Uber. So does Netflix. Here is when to pick which and why most companies use both. Let's start with SQL. SQL databases, also called relational databases, store data in tables with rows and columns. Think of a spreadsheet, but with strict rules. Every row follows the same structure. Every column has a defined type. You define the schema up front, and the database enforces it. The key properties of SQL databases are ACID, atomicity, consistency, isolation, durability. This means transactions are all or nothing. If a bank transfer fails halfway, the whole thing rolls back. No partial state. No corrupted data. SQL databases use relationships. You have a users table, an orders table, and you join them together. This avoids duplicating data. One source of truth. Examples of SQL databases: PostgreSQL, MySQL, Microsoft SQL Server, Oracle. These have been around for decades. Battle-tested. Production-proven. Now, NoSQL. NoSQL means not only SQL. These databases break free from the rigid table structure. Instead of rows and columns, they use documents, key-value pairs, graphs, or wide columns. Document databases like MongoDB store data as JSON-like objects. Each document can have a completely different structure. No fixed schema. Key-value stores like Redis are basically giant hash maps. Incredibly fast for simple lookups. Perfect for caching. Graph databases like Neo4j store relationships as first-class citizens. Great for social networks, recommendation engines, fraud detection. Column family stores like Cassandra spread data across many machines. Designed for massive write throughput. Now, the 5 key differences that actually matter when choosing. Difference 1. Schema. SQL has a fixed schema. You define your tables, columns, and types before inserting data. Changing the schema later requires migrations. This is rigid, but it guarantees data integrity. NoSQL has a flexible schema. You can add fields to documents without changing anything else. This is fast to iterate on, but you lose guarantees about data shape. Difference 2. Scaling. SQL databases traditionally scale vertically. You get a bigger server, more RAM, more CPU, faster disk. There's a ceiling. NoSQL databases are designed to scale horizontally. You add more machines. Data distributes automatically. This is why NoSQL handles massive scale, millions of writes per second. Difference 3. Relationships. SQL uses joins. Need data from 2 tables? Join them in one query. Elegant. Powerful. But joins get expensive at scale, especially across distributed systems. NoSQL uses denormalization. Instead of joining, you duplicate data. An order document contains the customer name directly, not a reference to a customer table. Reads are fast, but updates can be complex. Difference 4. Consistency. SQL guarantees ACID. After a write, every reader sees the updated data immediately. Strong consistency. Essential for financial transactions. NoSQL often uses base. Basically available. Soft state. Eventually consistent. After a write, different nodes might show different values, temporarily, but eventually, they all converge. Faster, but you trade immediate consistency. Difference 5. Query language. SQL has a standard query language. Select, from, where, join, learn it once, use it everywhere. Decades of tooling and expertise. NoSQL databases each have their own API or query syntax. MongoDB uses its own query operators. Cassandra has CQL, which looks like SQL, but isn't. Redis uses commands. There's no universal standard. So, when should you use SQL? Use SQL for banking and financial systems. ACID transactions are non-negotiable. A transfer must be atomic. Use SQL for e-commerce, orders, inventory, payments. These need strong consistency and relationships. Use SQL when your data has clear relationships. Users have orders. Orders have items. Items have categories. Relational data belongs in relational databases. Use SQL when data integrity matters more than speed. Healthcare records. Accounting systems. Legal documents. When should you use NoSQL? Use NoSQL for real-time analytics. Millions of events per second. Time series data. Metrics dashboards. Use NoSQL for content management. Blog posts, product catalogs, where each item might have different fields. Use NoSQL for caching. Session data. API responses. Anything where speed matters and data is temporary. Use NoSQL for social feeds. Activity streams. Notifications. High write, high read workloads with simple access patterns. Use NoSQL for IoT data. Sensor readings from millions of devices. Massive write throughput. Append-only patterns. Now, real examples from companies you know. Instagram. They use PostgreSQL, the SQL database, for user data, relationships, and core application state. But they also use Cassandra, a NoSQL database, for their activity feed and notification system. Billions of writes per day, where eventual consistency is acceptable. Uber. They use MySQL for trip data and accounting. Strong consistency for payments. But they also use Redis for caching and real-time dispatch. And Cassandra for their massive logging and analytics pipeline. Netflix. They use PostgreSQL for billing and account management. But Cassandra handles their viewing history, recommendations data, and everything that needs to scale to 250 million users across 190 countries. See the pattern? These companies don't pick one or the other. They pick both. So here's the real answer. It's not SQL versus NoSQL. It's SQL and NoSQL. The question isn't which is better, it's which is better for this specific problem. Need ACID transactions? SQL. Need horizontal scale? NoSQL. Need complex queries with joins? SQL. Need flexible schema for rapid iteration? NoSQL. Need strong consistency? SQL. Need high write throughput? NoSQL. The best architects don't have a favorite database. They have a favorite question. What are the access patterns? Start with how your data will be read and written, and the right database reveals itself. Most production systems today are polyglot persistent. They use multiple databases, each optimized for a specific use case. That's not complexity for the sake of it. That's choosing the right tool for each job. Next video, how message queues work and why every distributed system needs them. Subscribe to Tech Growthspire.